Hello everyone. Today I'd like to share our recent work on retrieving the leaf area index, or LAI, using two-angle high-resolution satellite images. Let's start with the basics. LAI is defined as the total one-sided leaf area per unit horizontal ground area, and is a key parameter for understanding vegetation health, productivity, and its role in the energy, carbon, and water cycles. Traditionally, LAI is retrieved using complex physical models, especially radiative transfer models. These models first establish a physical relationship between reflectance and canopy parameters. Once we have reflectance observations at certain angles or wavelength, we can try to retrieve parameters like LAI. However, such models usually rely on simplifying assumptions. For instance, that the canopy is uniform and continuous, which can lead to poor accuracy in complex or heterogeneous environments. A more advanced model is PathRT. It inputs detailed 3D canopy structure and uses ray tracing to simulate how light penetrates through the canopy, producing gap probabilities for different viewing angles. It's highly accurate, but the problem is that this 3D information is only available at local scales. So what did we do? We simplified this model and developed PathRTS, where the S stands for simplified. It preserves the core physics but significantly reduces data requirements. Instead of using 3D canopy structure, we use high-resolution satellite images at two angles. We directly classify the images to extract the four geometric-optical components: sunlit ground, sunlit canopy, shadowed ground, and shadowed canopy. Using the observed gap probabilities at the two angles, we then extrapolate the gap probabilities at other angles. This extrapolation considers the general ground shape. Once we have the multi-angle gap probabilities, along with the remotely sensed reflectance and the component spectra of leaves and the background, we can invert this model to retrieve LAI. We tested our model across multiple scenes, both synthetic and real world. The results were impressive. LAI retrieval accuracy nearly matched that of the full PathRT model. In short, simpler inputs, comparable accuracy, and broader applicability. Our method opens new doors for large-scale vegetation monitoring without the burden of complex 3D data. Thank you.